This is the Algebra 2 review for test 1 through 30. All right, so questions that we want to be able to do, something like this where we have, let's say, 16x, let's say minus, let's see, 10, or sorry, plus, we'll do plus 10z minus 8x. What else do we want? Plus 6z plus 12. All right, what is the basic principle at play here? What are we trying to do here? Because really what we want to do is we want to simplify this expression. But how am I going to do that? Combine like terms. What are my like terms? 16x and negative 8x. What's 16x and negative 8x? 8x. Okay, so we got 8x. What's next? 10z and 6z. What's 10z and 6z? 16z. Yeah, be careful with that, because the reason we're talking about this today is because those are mistakes we'll make tomorrow, right? Plus 12 doesn't have any like terms. So that's what we would get potentially here. I'm trying to think. I don't think that what they would do, I would say that like in future math, what we could do is we could factor things out of that. All right, if we could simplify that down any further, I would divide it by 4, right? That would give me 2x plus 4z plus 3. Okay, so if I saw a simplified version of this, let me see if you're getting anything like that. Yeah, no, I don't think that you'll get anything like that, but anyway. All right, let me look at another one. All right, this next one is going to involve adding matrices. Adding matrices. So like, let's say we have B equals, and here I'm just going to let you guys kind of pick numbers. Give me some numbers to work with. 10, 3, 7, and 2. Okay? And then we're going to get matrix C. Okay, we want to add, give me some numbers here. 4, 5, 10, 15. Okay, 4, 5, 10, 15. All right, we want to find B plus C. Okay, now they could really easily switch this around and say, find C plus B. You want to be careful with things like that. But we are just adding here. Okay, so the new matrix, give me some things I'm actually adding together. If I'm doing B plus C, 10 and 4, 14, 3 and 5 is 8, 7 and 17, 2 and 15, 17. That should be it, right? That should be really, really easy to do. Don't make it more complicated than it needs to be. But also things to remember. I'll tell you, for instance, that let's say we got something like this, right? That's going to change things, right? All right, that's going to end up changing this one and this one down here. Let's look at it now. Negative 3 plus 5, 2. Okay, 7 plus negative 10, negative 3. Okay, the question on the test is going to throw some negatives in there. All right, so adding matrices, really not too bad. Okay, let's see what else we got. Increase. Somebody give me percent increase or decrease. So somebody give me a 2-digit number. No. It's giving me a percent, just a number, 50. Okay, if you want to keep them really easy, we're not 36. Okay, 36. All right, so we want to know, let's look at the percent if we're going from 36 to what? 68. Okay? We're going from 36 to 68. We want to know what is the percent increase or decrease. So let me remember what my formula is for this.
It's the old
New minus old
over the new.
over the old, or original. New minus original over original. So what is new here? 68 minus 36 over 36. All right. So here's the question. Looking at it, should we be able to tell if this is increase or decrease?
Yeah.
What is it? It's what? I heard decrease. It's increase because I'm going from 36 to 68, right? Okay, so what is, does anybody know what the decimal I get here is? 0.8 repeating, right? All right, so let's say I wanted you to round to the nearest hundredth. So I would be 89%, right? And would it be increase or decrease? Increase. Now, let's prepare ourselves. Could it be the other way around on the test? Could it be 68 to 36? Yeah, okay. So, but is it going to be the same percentage? So let's try that. We're going to go from 68 to 36. All right. So what's my new number now? 36 minus 68 over 68. All right. What decimal does that give you? Probably goes ahead and gives you a negative number, right? All right. So if it's negative, we should already know it's going to be decrease. Negative point what? 0.47. What's the next decimal? 0? Okay. So we would have a 47% decrease. Okay? So are we a little bit more prepared than we were for that question last test? Right? 'Cause I think you saw something like that last test, right? Okay. All right. Number 4. Let's see. We want to solve for a in this case. Let's do 6 times a plus 10 plus 12 equals 54. Okay, I want to solve for a. It's the first thing I do. Jewel, what's the first thing you do? Subtract. Distribute. There we go. Go ahead and tell me what you get with the distribution. 6a plus 60? 60, right? Because distribution is multiplication, correct? Plus 12. Plus 12 equals 54. Okay, now what do I do? Subtract 12. I could do that. That wouldn't change my answer, but could I add 60 and 12? Are they like terms? They're constants, right? They don't have variables. I could go ahead and combine those. But I'll go ahead and do that. Let's subtract 12. We got 6a plus 60. What's 54 minus 12? 42. Okay, now what would you do? Subtract 60. Okay. All right, it's giving me 6a equals probably a negative because we're subtracting more than what's there. The difference between 60. What is that? Negative 22. I don't. Try that one later. Okay. All right. So subtract by 6 on both sides, and you're getting a equals what? Negative 3. Okay. All right. So distribute. You can subtract twice if you want, or you could combine like terms and subtract the 72 from 54. It's not going to change the answer. Okay. All right. Number 5. Try to be conscious, try to get through as much of this as we can. We're going to see something where we're talking about a constant rate varies directly as time elapsed. Okay. So constant rate varies directly as time elapsed. Okay. Which would give me a k here, correct? We're talking about direct variation. Do you guys remember direct variation? It was the same equation as y equals kx, right? All right. So because they don't give me an inverse, I can just leave it as y equals tk. Does that make sense? All right. Varies directly as time elapsed. Basically, if we knew that, let's say we knew the speed of something, we knew it was 700 feet per second, right? My rate would be that right here. And we wanted to solve and find out how much time it would take. Okay. Let's see. We want to know how long it would take for something to travel 11, let's say 12,000 feet. Okay. So one of the things I want you to understand is that distance equals rate times time. Okay. That's essentially what we're kind of talking about here is distance, rate, and time. So if my question deals with 12,000 feet, that's my distance. Okay. My rate is the per second that something is moving. That would be the 700 here. And then I would be solving for time. Okay. So I would rather set it up like this. In that case, in order to solve for time, what would I do? Divide by 700. Okay. And it's kind of a made-up question, but what is 12,000 divided by 700? 17.14. So it takes 17.14 seconds for, if something is traveling at 700 feet per second, to go 12,000 feet. Does that make any sense at all? Okay. All right. This next one is a product matrix. Okay, number 6. Seeing something like this. Let's say we have matrix A, and it is a 3 by 2, and matrix B, it's a little different. It's a 2 by 3. And we want to know what is matrix A times matrix B. Real quick, give me some numbers. 5, 7, 8, 2, 4, 3. All right. Not a whole lot of variety, no real negatives or anything. Listen, I mean, if you don't kind of make the question challenging, then you're not going to be challenged to the point to be prepared for tomorrow. So just keep that in mind as I give you guys an opportunity to create the numbers. All right, give me some more numbers. Negative 20. Okay, I heard 6. Negative 8. 18. Negative what? Negative 76. Okay. Okay. What? 4. All right. So we want to know what is matrix A times matrix B, if that's possible. Well, the first thing I have to determine is it possible? What are the dimensions of matrix A? 3 by 2. And what are the 2 by 3? All right, so that's the first thing I got to do. And I'm looking at these numbers. Is it possible? Okay, what are the dimensions of the new matrix? 3 by 3. So I'm going to come down here and I'm going to make this 3 by 3 matrix. Now, you might do this in a calculator to check your answer, but what I'm going to do is I'm looking at this spot right here, and I'm saying, okay, that is first row, first column, right? So the math that I'm doing to get that number is 5 times negative 21 plus 7 times 18. What's that? Oh, I'm sorry, 20, just 20. So 5 times negative 20 should be what, negative 100? And I don't know what 7 times 18 is. 105? 126. So I should get 26 there, right? Okay. Now, let's, we don't want to spend all day doing this question because we have 9 different things to find, which means we're going to have, you know, several different multiplications, a lot of addition, a lot of those types of things in there. Somebody pick a random row and column. Row 2, column 2. So that would be this spot right here, right? Okay. That would be second row, second column. So that would mean taking this row and this column. Does that make sense? So the multiplication, 8 times 6 plus, okay, so we should understand how the address of the new matrix affects what I'm multiplying and what I'm adding. 8 times 6 is 48, right? Plus what should be a negative, probably 152. All right, so negative 152 or even 152 minus 48 should give me like negative 104. Negative 104 is going to go right there. All right, so do we have a basic understanding of how to do something like this? Now, the numbers on the test are going to be way easier to work with, right, than this, but that's why I wanted you to prepare with harder numbers. Do we understand how to multiply based upon an address? Okay. And do you guys know how to use your calculator to check your answer? Okay, good. Am I going to just use my calculator on that? No. Okay. All right. We want to find the determinant of a matrix, and it's a 3 by 3 matrix. Okay. Something like this. Give me some numbers. These don't have to be super difficult numbers, but just give me a couple of negatives in here. Negative 20. You could probably keep them single digits from here on. Negative 8, 5, 7, 2, 3, negative 4, 9, and 6. Okay. All right. So what I'm going to do is I'm going to show the work. This is all I'm really expecting you guys to do pencil paper wise. So I would get negative 20. Okay. That's this. And then parentheses, what I want is 2 times 6 minus 9 times 3. Do we understand that? 2 times 6 minus 9 times 3. Okay? All right. The next one is minus negative 8. Okay? All right. So I'm working with that. All right. I have an invisible line drawn underneath of it and across it. So I'm doing 7 times 6 minus negative 4 times 3. Okay, we're good there. Plus 5 times 7 times 9 minus. Okay. Now, do I need to be aware of these negative positions? Yes. One of the big mistakes is forgetting those places. Now, I could go ahead and solve this pencil paper at this point, or I can make a 3 by 3 matrix, right, and go to math determinant and have it do it. But what I do need to see is I need to see this line at least. You can have your calculator find a determinant, but I want to know that you know how to set it up. Okay? You don't have to go through here, for my sake, and do the multiplication, the addition, subtraction, and all of that. Does that make sense? So you know what's expected for tomorrow to get credit? Okay. All right. 8. What time are you guys out of here? 36. All right. Here you're going to need to solve an inequality. So something like x minus, let's say x minus 12. Let's see, minus, let's say minus 10 is less than, let's say negative 2. First thing I need to do is determine if this is possible. In order to determine if this is possible, I'm going to go ahead and isolate the absolute value. What do I need to do in order to do that? Add 10 to both sides. All right, so I have absolute value of x minus 10 is less than 8. Is that possible? Oh, I'm sorry. X minus 12. Sorry. Is that possible? Yes. Okay. Now I'm not going to go through the whole thing for sake of time, but I do need to set this up twice. X minus 12 is less than 8. Then what's the other equation that everybody forgets? X minus 12 greater than negative 8. And I need to solve both of those. And once I've done that, I need to put that on a number line. Okay, well, we'll go ahead and finish. 12, so that's giving me x is less than 20. Add 12, right? X is greater than, what, 4? So on a number line, I'm seeing 0. I got 4, I have 20. These are both open circles. X is greater than 4 but less than 20, so I'm getting that line right there. Does that make sense? Okay, I have to solve both equations. Okay, number 9. Okay, number 9 is going to give you something along the lines of f of x, let's say, is 3x plus 2. G of x is, say, equals negative 8x plus 11. The question would be find f of g of x. What they want you to do here is multiply those two things together. So that means to FOIL. Okay? Questions there? Okay, FOIL those two things. Okay? Well, I'm giving you a video, but every second I give you is one less question you get to look at. Okay, I'm not trying to be rude. 10. 10 is a good one to be prepared for. X squared, let's see, minus 64. Factor that. Notice that there's no x. Notice that I'm subtracting a perfect square. So I should get x minus the perfect square, x plus the perfect square. Okay. 11. Okay, at least you guys can get, if you study these, at least you can get above a 50%. All right, we want to write an equation in slope-intercept form. Let's say I have 3, 7, and 6, 8. Write an equation in slope-intercept form that passes through those 2 points. All right, well, the first thing I have to do is come up with a slope, right? So that's y1 minus y2 over x1 minus x2, right? This is x1, this is y1, this is x2, this is y2. That's going to give me my slope. Once I have a slope, right, I can do y minus y1 equals m times x minus x1. I can use these coordinates here for this 7. It's going to go here. This 3 is going to go there. No, it's y minus y1. Are you talking about up here? It doesn't matter. You can do y1 minus y2 over x1 minus x2. You can do, you can do y2 minus y1 equals x2 over x2 minus x1. It won't change the slope. Okay? But once I have the slope, whatever this solution comes out to is going to go in here, and that's going to give me my equation in slope-intercept form. Does that make sense? All right. So what I'll probably do is with the other Algebra 2 class, I'll pick it up from question 11 and do this video as two different parts. Does that make sense? Okay.